hear me okay? Because my voice is bad on because of the silence. So, okay. Brydia, how about now? Can you hear me better? Yeah, sorry about that. Um, my name is Jacob. I'm with the Waco District Area um, Office, and Bob and I, we're going to tag team together and give y'all guys an update on the I-35 construction projects update. And Waco District is sandwiched between three metros districts, Dallas-Fort Worth in the north and Austin in the south. And this is some of the challenges we are dealing with. Depends on the days and the night, the week of the day. We may have up to 35% truck traffic, and with over $100,000 vehicle per day. The total construction projects cost is about $2.1 billion. That includes utility relocations and right-of-way acquisition. All the projects north of Waco's are basically either completed or substantially completed. Its total length about 33 miles. And this is just a snapshot of what a rural, typical I-35 in Waco District looks like. This picture was taken back in December of 2011. It is at the McLennan and Hill County line. As you can see, the contractor is actually working, preparing the right-of-way at that time. The typical 35 we have is two-way frontage road with zero shoulder, two lane on each direction with a narrow median, and a very out-of-date a design for the entrance or exit ramps. And this is the same location taken about 2 weeks ago. As you can see, the frontage road is a one-way frontage road with two lanes with shoulders, also three lane at each direction. And we also reverse the ramps. Also, you kind of hard to see, we install some of the DMS along the corridor. And we have actually 6 or 7 active projects going on south of Waco. They are all the way from Robinson's to Salado. All these projects, we have built-in milestones, incentives for early completions, and liquidated damages. And we're trying to get the contractor to finish their work as soon as they can. And the expected completion dates is around 2018. During this time, all our ITS infrastructures are put on a temporary setup, All right, so what kind of ITS setup we have on the 35 corridors? First of all, we have some Bluetooth readers. There's about 43 of them along the corridors. Basically, what they're doing is doing speed detections. You can go to my35.org, and you can actually look at the actual real-time travel speed along the corridor. Along with showing the real-time travel information, we also can use this travel map to kind of approximately locate if there's any incidents along the corridor, because when the speed drop below 60, it will turn to a different color. And every day the system generate operation reports to us. And basically, it just tells you the travel speed and any delays along specific locations along the corridor. For example, from Temple to Waco, the travel time usually is about 30 minutes. And so if we look at a report and we find out like 2 in the morning the previous night, the travel time went up to 45 minutes, then we can kind of figure out whether it is a lane closure, caused by a lane closure, or accidents, or maybe just something that we don't know. So that's something that we can look into. And we have these devices installed since the start of the job. So basically, we have 4 years of data archives. The other device that we use is Wavetronics. We have about 19 locations. Basically, we are doing that to measure the traffic volumes and the classifications of vehicles. It is really for calculations for our queue projection analysis. Basically, for example, if the contractor in Temple wants to close a lane on Interstate 35 on Thursday night at 7 p.m., we can use the information from Wavetronics to figure out what will be the queue distance because of this lane closure. And then based on that information, then we can determine whether we need an anti-queue system that will advance warn the public about possible delay and possible backup. With projects along the corridor, sometimes we have multiple contractors wants to do a lane closure on the same night at the same time, and maybe 10 miles apart or whatever. So we can use the same information to project the queue if there are for two lane closures. And I remember there are times that we have to talk to the contractor, one of the contractors, to ask them to do the lane closure in a later night that will minimize any impacts along 35. CCTV picture is just worth 1,000 words, and we can use those informations for incident management, and we can also use the information from the cameras to see if we look at the section of the roadway is clear, but on our speed map it shows the travel speed is less than 50 miles an hour, for example, then we can kind of try to look at our equipment to see whether we have a malfunction with our Bluetooth devices. Let's see. So when we're talking about temporary setup, these are what we're talking about. The Bluetooth devices are mounted on a wooden pole, or sometimes we just mount it on we locate a large sign and we just mount it on the sign pole. And these are more a permanent setup for our Bluetooth devices and Wavetronic devices. Basically, we are mounted on a overhead sign bridge or cantilever sign, or sometimes we just set it on the standalone steel pole. Per our I-35 incident management plan, we have designated alternate routes throughout different sections of Interstate 35. Like for example here, this is Loop 340 around Waco, so in case there is any incidents around here, we can divert the traffic around Waco. And we're using State Highway 81 to go around Hillsborough in case something happened on 35 here. And along with alternate routes, we have Bluetooth reader, and also sometimes we have CCTV setups along those routes that just give us extra information in case we have to direct the traffic to the alternate route, and we can monitor the travel speed along those routes. And we also tap into our Vivids at major intersections. That's just another tool that we use to monitor the traffic. And Bob will cover the comparative travel signs, travel time information later on. Okay. Bob?
Okay, can everybody hear me? Nobody's ever accused me of not having a big mouth, so I'll just go from here. One of the things that's been really important and a goal of the project since the very beginning is that when we started working with the Waco District, there really wasn't any infrastructure in place. And we're talking about a 100-mile construction project, so we don't have the capability for permanent installations and power. And Jacob very nicely showed how we've been working throughout the corridor and using temporary infrastructure and moving that to permanent infrastructure. Well, the other goal of the project is that as we move towards the end of the construction, we integrate all of this within TxDOT's traffic management software, Lone Star. And so this slide really covers really the interactions of how this system is working with Lone Star. So in 2011, when we started this, we actually started it with a special implementation of Lone Star run out of the Traffic Operations Division in Austin. We did that for a couple reasons. The first one was we knew that there were going to be lots of changes necessary to the infrastructure and constant changes to the IP addresses and getting everything set up. We also really, in all practical sense, didn't really have a very good idea of how this was going to work. We didn't know if we were going to have to make adjustments to Lone Star and those types of things. So TxDOT was terrific working with us, Traffic Operations Division, with extensive support from Southwest Research Institute, set up a special instantiation of Lone Star running out of TRF in Austin to actually handle this entire project. And we ran out of that instantiation for about 4 years. And in 2015, early 2015, I think around May, we started to transition the implementation to run under Fort Worth, which is in the hierarchy of TxDOT and TMCs. Waco is a child TMC of the parent of Fort Worth. So that's what we started to do, and that coincided with basically the sections north of Waco being largely complete with their construction efforts. So currently, all of the CCTV is done through Fort Worth, and we're working on naming conventions and statewide website information and adjusting all of that. And shortly, I'll talk about travel times north of Waco, but very soon those will be taken over. Instead of TTI producing the travel times and injecting them into Lone Star running out of Fort Worth will be producing those travel times north of Waco. So a continued goal of the project is the integration. The concept is that when we, TTI, are no longer under contract to assist the district, that all of their structure, all of their infrastructure, should say, is operational 100% underneath Lone Star. So let me just back up for a little bit. You've heard presentations throughout the last several years about I-35 traveler information and what we're doing. And we kind of do a little bit of an update every year, and I have several initiatives that I want to give you an update on this year. But I just wanted to remind everybody is that everything, back up, hit the wrong button, sorry. I just wanted to remind everybody, everything that we're doing with respect to traveler information in the district and for the corridor really starts with 3 basic questions. What are travel conditions like now? What are they going to be on any part of my trip? And where am I going to be delayed, usually by lane closures? That's evolved a little bit into where am I going to be delayed by incidents as well as lane closures, although the starting point was really lane closures. And from our first public survey, this is what the public told us they wanted. They want delays, travel times, incidents, snapshots, speeds, they want everything. We've been able to do this and accomplish this over the course of several years. So just an update on several different aspects of things. We mentioned travel times north of Waco. As Jacob said, the construction north of Waco is complete. I think there's a little bit of punch items work still going on. And we have some interesting situations where we've got, our permanent DMS up and running, and here's our PCMS doing travel times. So that's probably not a very good public perception type of deal. So we're working on changing that, and you'll see the goal here at the end of October 2015 to actually move out all the PCMSs north of Waco out of the corridor and transition travel times up onto the DMS. Well, what does that take? That takes a lot of logistics behind the scenes. All of the data that is being processed by our Bluetooth algorithms at TTI needs to be fed into Lone Star. Lone Star is doing that. It's firewall rules. It's checking with a lot of different people on different things. We're actively working on all those processes and getting everything set up and working on the messages. The messages can be expanded as well. On a PCMS, you've got 8 lines, or 8 characters per line times 3 lines. We settled on a very short and distinct message, destination, distance, time, and standardize that across the corridor. On a DMS, you have the opportunity, obviously, to have a much more extensive message. So we're looking at the message sets that are most appropriate for the traveling public in that time or in that corridor, which is largely rural, as opposed to some of the travel time implementations in other places, which are largely in urban areas. You've heard me talk, if you've been here before, you've heard me or some other folks from the Waco district talk about our construction delay forecast signs. The concept of this was that we were going to do short-term predictions for the delays being caused specifically by construction, i.e. lane closures. That requires a lot of real-time data, which we have. End of queue warning systems, Bluetooth, Wavetronics, all of that we have and we can control and we get that information. The other information that is necessary for that, however, is a really good understanding of exactly what's going on at what time internal to the lane closure. That we don't have a really good way of handling. If we predict, for example, that the lane closure is supposed to start at 7 o'clock, and I won't go through all the math and bore you to tears with all of that, but if we predict that a lane closure is supposed to start at 7 o'clock, our algorithms kick in, we start to estimate what the capacity of the lane closure is going to be, we start to predict how long that queue is going to be in 5-minute segments going back, and as it turns out, the lane closure doesn't start until 7:30 or 8 o'clock. Well, our algorithm's already been running for an hour, telling everybody that there's going to be these delays, and yet the lane closure hasn't even started yet. So the bottom line is we don't have that good source of information, and when you start to do that, you find that your prediction window for the correctness of the algorithm, instead of being nice and solid, starts to really go out like that. For that reason, we've actually canceled this initiative in terms of putting signs on the side of the road. It's still worthwhile to investigate as we move forward, but it's not something that's ready yet until we can control all of the information sources that are necessary. So what did we do with all that infrastructure that we were gearing up and bought? Glad you asked. What we're moving forward with is comparative travel times. Jacob mentioned implementation or instrumentation around the loop. Loop 340 and Loop 340 around Waco and Loop 363 around Temple are very viable routes for when there's an incident or congestion or lane closures that are significantly backing up traffic in those areas. Temple will be under construction until 2018. So having Loop 363 instrumented and signed so that people know what the comparative travel time is on Loop 363 to the west side of Temple versus going straight through on I-35 could be a very positive and strong travel information initiative. So we're working on doing that. It utilizes the Bluetooth infrastructure. The alternate loops have been, or the loops have been instrumented with that. We're building the software module that's necessary for that, and doing the field site investigation and deployment work to actually build these signs and put them up as permanent infrastructure. And it utilizes the same inserts that we had previously that we were using for the construction delay forecast signs. So in terms of a sunk cost for equipment, it's all the same. These will be solar powered. In the future, they can be converted to DC power, AC power. Failed electrical, no, just kidding. They can be converted to AC power when all the construction is complete, and they can get utility power drops in the area. And the estimation for when those are active would be January 2016. In addition to that, you see these signs here. They look very similar to the signs 2 slides ago. We changed the background, made it from orange and black to green and white. But the difference here is that we're not trying to predict a short-term delay. We are going to tell people what the current delay actually is, simply based upon a long aggregation of Bluetooth across the corridor. Because north of Waco is complete and south of Temple is largely complete, we're concentrating on the area between Belton and Waco, and we'll put up 2 signs, one in each direction, 2 zones for each one, so that you see the current delay associated with each one of those sections. Again, the implementation time frame is similar to the comparative travel times, solar powered, working on the field site investigation and deployment aspects in January 2016. And this, I would also point out that this delay and the information here will also correlate directly to the real-time traveler information map that's available via my35.org. We've spoken before about end-of-queue warning systems. To date, we've had more than 300 deployment nights of the end-of-queue warning systems. We've also had a number of specialty deployments related to DPS fatality investigations, semi-permanent installations for lane closures or work on the roadway that was going to be taking place for a significant amount of time. And there's also one that's upcoming called the Waco 6 Bridge Package, which, because Waco isn't funded for the full reconstruction right now, they're going through and doing basically maintenance work on 6 bridges within Waco, and that is projected to have some significant delay associated with it, which is another reason to do comparative travel times around Loop 340 to the east side of Waco. So TxDOT really deserves a lot of credit. They pioneered this approach nationally. Several states are now following that same approach, and in fact, many of the states simply picked up TxDOT specifications, crossed out the word TxDOT, wrote in Pennsylvania, or I'm not saying Pennsylvania did that, they just wrote in another state, oops, and used those same specifications. What's been done also inside TxDOT, though, is there's a more complete process. There's business rules for what end of queue plan do you put in place. You know, do I need 2 miles of this protection? Do I need 8 miles? What really is the tipping point for those? And also an O&M process that follows all of this, so that we know when the system is performing as expected. Perhaps a barrel got hit, and you know, there's no visible damage to it because they're pretty hefty barrels, but perhaps the equipment inside got hit. So there's a whole concept, a whole system of information that takes place on this that other states are still looking at, although other states are doing things in terms of alternative contracting to accomplish some of these things as well. Overall, we've also been able to, because of the 300 deployment nights, take a look at things, and our work zone experts like Jerry Ullman and others within the Institute have determined that overall there's an average of about 18 to 41% reduction in crashes over what would have occurred if the end-of-queue systems were not in place. Moving quickly on to incident messaging. Incidents are a primary concern within the corridor. We've completely revised our incident messaging alert system to include detour routes or alternate routes, depending on what TxDOT determines they should be. We plot those on the real-time map. We have new icons. We have a set of directions that come through that tell the driver exactly how to navigate the detour or alternate route, and that's been very positively received so far. Finally, about traveler information outreach, our lane closure email notices, we have several different types of that, daily, 7-day, high impact only. You can see from the graph we've kind of topped out of that. We have kind of flat growth in that area in terms of over 4,000 total subscribers. Incident messaging continues to grow. We have over 2,400 subscribers across that aspect of our information outreach, and that continues to have a very high rate of growth. We have our real-time map that incorporates things like corridor delay, detour route, alternate route conditions. That's where Jacob was talking about before, all of the alternate routes that are instrumented with Bluetooth, those will be available on the real-time map as well. And then finally, and that just shows a picture of the map with our section delay on it. And then finally, Twitter feeds. We've been doing a lot with Twitter. One of the metrics for Twitter is called an impression. Basically, it's the number of times that you tweet out about something times the number of people that have actually subscribed to that feed and seen that tweet. And in the last year alone, across the 2 Twitter feeds that we have available for the Waco district, we have over 6.2 million impressions on those. And we're adding 2 new Twitter feeds for lane closures and incidents. And I would like to point out that this metric here of 6.2 million impressions is not inflated. We do not, and I never say this word right, retweet. I actually said it right that time. We do not constantly retweet the, didn't say it right that time. We do not constantly repeat the information. If there's a slow speed in a section or travel time is slow, we don't just keep blasting it out and artificially increasing our impressions. We blast it out once, and we only repeat that information if a certain time period has gone by, like 15 minutes, and the condition is still in effect. So we're trying a very full-fledged approach all the way from infrastructure to information that's on the road, various different initiatives to travel information so that people can get it any which way they can. And with that, Jacob and I would be happy to answer any questions.